Hey, hello, this is the CSM Week 12 worksheet video walkthrough, and today I'm going to be going over the what would Python do problem for the linked list section. So let's get right into it. You guys have for sure seen linked lists before in class, but a quick overview is that linked lists are a recursive data structure for representing sequences, and so they consist of a series of linked objects, each of which have two attributes, a dot first and a dot rest, and the dot first attribute can also contain another linked list. So just for future reference, it doesn't always have to just contain a number or a string or anything like that. It can also loop back and be a link object again. And the .rest attribute, on the other hand, is a pointer to another link object or link.empty, which is just a none type value. An important thing to note is that link.empty is not link object, and that is because link.empty does not have a .rest attribute, as it is just a none type value. So as we can see here, in the class, linked lists have .first and .rest attributes, and for it to be valid, rest must either be a link.empty or it must be an instance of link again, which is just another link object. And so linked lists are very much a naturally recursive data structure, much like trees. And so they lend themselves to a lot of cool, but also maybe confusing recursive problem solving. And so this problem kind of gives us an example of how we can use recursion to kind of get things done quicker and to act on every link object in the linked list easily. So yeah, this is a pretty helpful example of that. But for now, let's get right into the what would Python do. And so for future reference, when you're assigning something, Python will not actually output anything to the screen. But in this problem, just because we want some practice, anytime we're assigning something, I'm just going to draw a box and pointer diagram so we can visualize it and also understand it better. Okay, so let's start with A. And so like environment diagrams, let's just be clear and say and specify that this is an A named object. So okay, so this linked list also is very helpful to represent link objects like a box with two sections. The first section is dot first and the second section is dot rest. It makes visualization really easy, and it'll be really helpful in later sequences, especially for what would Python do problems. Okay, so this first link object we're going to represent with this first box. And so this link object has a dot first value of 1, and the dot rest value, so the second argument in this link object, is going to be another link object. So we're going to point this to yet another link object. And so this first link object, number 2, is going to have a dot first value of 2 and a dot rest value of another linked object, which dot first value is 3. This is our third one. And as we can see, this this link object does not have a second attribute, so there's no dot rest, and therefore it is the end, and so we can denote that with a slash or a link.empty. Yeah, so that's the end of our linked list. And now we're actually going to print something because we're no longer assigning things anymore. And so a dot first, well, this is a, and the dot first value, well, the first dot first value is going to be 1. Okay. Now, remember that linked lists are mutable. So if you reassign something, we can change the linked list immediately by itself. So yeah, so previously the a dot first value was 1, as we just found, and now we can reassign it to a 5. So there we go. Okay, and now they're going to ask us the a dot first value again, but we just reassigned it, so we know that it is 5. Okay, so now it's going to be a little complicated. We're going to start working with dot rest values. So a dot rest dot first. This is a. The dot rest value is this, and it's pointing to another link object. So we're going to look at this now. And so the dot first attribute of this next object is 2. So that is our answer. Okay. And now we have a dot rest dot rest dot rest dot first, or 4 dot rest. I don't know if I said that, but okay. So a dot rest, the first dot rest, is pointing to another link object. So we're going to look at this linked object's dot rest, which is pointing to yet another link object. And now we want to look at this object's dot rest as well. And so this is link.empty as we previously found, but now we want to access the dot rest value of this section, which is link.empty. So essentially we want link.empty, which we found is this entire part, the dot rest dot first of that. Well, actually, remember, like I said previously, link.empty is not a link object because it does not have a dot first and dot rest attribute. It is a none type value. And so this will return an error. More specifically, it is a tuple object, has no attribute to rest error. So link.empty does not have a dot rest value, and so it'll return an error every single time you try to access it if you do. Okay, so now we're going to go a little more confusing and deeper into linked lists. So I'm just going to redraw it here so we can see it better. Oops. So this is what we had previously. Okay, so now we want to kind of reassign the dot rest attribute of A into A. Okay, so obviously this kind of cyclical assignment is a little bit confusing, but if you do a lot of practice and you kind of just follow the instructions like directly about what they're trying to tell you to do, then it'll get easier as time goes on. So let's try to follow it very carefully so we don't get confused along the way. So a.rest is this part, and so this part is pointing to another link object, so we're going to focus on that now. And so the dot rest attribute is pointing to yet another link object, and we want to assign the dot rest of this object, which we saw was link.empty previously, into whatever A is pointing to. Well, A is pointing to the beginning of the linked list because, as we know, A.first is going to be this, indicating this link object. So we can reassign the A.rest.rest, which was previously a link.empty, into the beginning. So now we've created a cyclical type of linked list, and this linked list does not have a link.empty, so actually it will keep going infinitely because there's kind of no end to it. But yeah, that's something to keep in mind. Okay, so previously this gave us an error because there was a link.empty that we try to access the dot rest attribute of, but now it's not going to do that because there's no more link.empty anywhere. So a.rest first. So a.rest, which is this link object, dot rest of that one, which is this one, just pointing to another one, dot rest of this, which is this one, which we just reassigned. So now we're at the third dot rest, and now we want to access the dot rest of this. So this is pointing to another link object, and we want to access the dot rest of this object, and and we're going to finally access so the dot rest of this object is yet another pointer to another link object, and now we want to access the dot first of whatever that's pointing to, which is this one. So dot first of this one is going to be 2, and that is our answer. Okay, so now we're going to go into more of the repr string parts of a linked list class. And so repr is just a computer representation, and oftentimes that can be a little messy with like a bunch of numbers that represent memory allocation. So instead, we can override the repr function in a class to give us a prettier kind of version of whatever object we're trying to represent. And in this case, we override it and we can create a better representation. So they want us to represent or call the repr on link 1, 2, 3, and then which ends with the link.empty. So we can kind of go through this recursively, but once we start to see a pattern forming, we could just put our answer down and call it a day. So the first one, we actually represent this as box and pointer. Okay, so if self.rest, so this is self now. If self.rest is not link.empty, and it is not because this is .rest and it's not link.empty, then we create a new variable rest repr is equal to comma plus the repr of self.rest, which is the repr of all of this. And so we kind of recursively go back into it. And so the repr of self.rest is going to be 2 Actually, sorry, kind of messed up on this. Okay, yeah, so we have this comma, and now we're going to return hold on. Actually, yeah, sorry. This this should be a recursive implementation. So we get we call repr on self.rest yet again. And then every time it's going to try to return a link, a string plus repr of self.first plus rest.repr plus a closing bracket. So this is a little confusing, but we're just building up rest repr through recursion and then kind of returning everything and putting it all together. So in short, there is a common pattern we see emerging. We see a link, and then we see a repr self.first, which is just the value of every object, link object, the dot first value of every linked object in the list, plus a comma, plus plus a recursive call on itself again with the rest of the linked list. So if we recursively do this, we can see a pattern forming. And when we get to this third one, we see that the rest is an empty one, so we can just return nothing or return an empty character, and then close it with all of the brackets. So this is a pretty confusing recursion, but yeah, there's a common pattern here. So every time we're just going to return a link bracket, link parentheses, self.first repr plus the rest repr, which is just this function called on the rest all the way until we get to a linked.empty object. Okay. So our final representation, and this is a repr, so it's going to have brackets or quotations around it, is going to be this. And we can see that this is a way prettier representation than what it would have been without the overriding. Okay, so next, this is also going to implicitly call repr, but we're not doing it explicitly like we did in the previous problem. In fact, because we're passing a link object in itself, the computer will try to call the repr function that we defined here in order to give us back a nicer representation of a link list. Okay, so, but because we're not explicitly calling repr on it, there's going to be no quotations around it. So that's another important differentiator to think about. Okay, so like before, it's just going to be the same except without quotes. Okay, now we're going to go into the string side of things. So this is link 1, link 2, link 3. And now let's go to our function over here. And I'm just going to draw this function pointer. Okay, so this is an iterative function now. So we're going to start with the string equals this, and we're going to start building up on it. Okay, so while self.rest is not linked.empty, so the first iteration we see is not linked.empty, then we're going to append the string representation of self.first with a space. So the string representation of 1 is just a 1, and there's a space in between. So I'm going to do that with this space. Okay, and now self is equal to self.rest. So sorry, I forgot to put this part, but this is self, and now self is going to be reassigned to self.rest, which is this, which is pointing to this. So self is going to be pointing to whatever this is pointing to, which is this link object. Okay, now we do it again. Now that self.rest is still not linked.empty because there's still that portion left, we can append the string representation of self.first, which is 2 now, with a space, and now we're going to reassign self into here. Okay, so self.rest is linked.empty now, so we're going to exit the while loop and return this string plus the string representation of self.first, which is 3 now because this is self, and so this is self.first, plus a closing bracket. So that is our final solution. Remember that because we're calling string on it, we're going to need quotations around. So remember that there are spaces in between. Okay, so now we're going to try to print it instead. So when printing things, the computer implicitly calls the string function, but there's not going to be any quotes around it. So that's another important distinction to make. And for this one, we see that there is a nested link object. So let's kind of go back to our function and do this. We kind of already understand the pattern, so it shouldn't be too hard. So we have a link, and the link dot first is going to be another link object, as you can see, because this is going to be dot first. Oh. Yeah, so there's a little nesting going on here. So yeah, so this first link objects dot first is going to be this entire chain of linked lists, which is a little confusing. And then it's going to be dot empty for this first linked list. So let's see how this works out. Drawing it in a representation way. Let me clean this up. So messy. The dot first attribute is going to have another linked list. So this is link object 1. And then inside of that is going to be another linked list, as we denote link object 2 with 1. And then it's going to point to yet another linked list 2, linked list 3, and then there's nothing left. So this is going to be a third link object and fourth link object. And if we go back here to help you guys visualize it, this is first one, and inside is the second one, and then third one, and the fourth one. So this first one is the only one that contains a nested linked list. So our representation is going to look something like this. Okay. So let's redo this again. Well, string starts with a bracket, as we know, and while self.rest is not linked to empty. So yeah, so self.rest is linked to empty, as we can see here. So we're going to append the string representation of self.first, which is all of this. So we're going to recursively call this function again to try to flesh everything out, all the nested objects out. So we're going to recursively call that. And so we're going to have another string and another environment function, another environment frame, but because I'm not really doing that same notation, I'm just gonna plus string star, but essentially it's just the same string name in another frame. So it's going to equal another bracket. And while self.rest is not link.empty, oh my god. Okay, sorry, I'm so sorry. I actually drew this wrong. Actually, this is one link object. And then this first link one has third one. So this is how it should be represented. My bad. But yeah, nonetheless, it is still nested, this first one. And so it is going to be a 1. And so now the rest is going to be link.empty. And we're going to return that because it is link.empty. So this entire thing is going to be 1 now. And so we're going to append that onto our original string because we've returned out of this star environment frame. And now we're going to keep going like before. So now self is equal to self.rest. So it's going to be pointing to here. And so we're going to have a little space, do that, and then it's going to point to 3, a little space. And then we're going to close it with a bracket because now that self.rest is equal to link.empty, we can exit out of the while loop and kind of finish it off here. Okay, so our final representation, remember that this is a print. So it is going to be no quotations around it, but this is still calling string implicitly, but there's just going to be no quotations. And so that is our final answer for that part. Sorry for messing up the link representation. As you can see here, I noticed it later, but there was a bracket here. So real quick, there's going to be a first link object that represents this one, and then a link 1 in the link.first of this link, which is going to be another link object of just 1 in link.empty because there's no second argument here. And then so we go back to this first link's dot rest, which is all of this. So we 2 and then 3. But yeah, just kind of notice the parentheses. I missaw it. I didn't see a parentheses here, so I thought it was all one, which is pretty confusing for me because the solution says something else. But yeah, so there's a parentheses here, and this second attribute is going to be link.empty. So we know it's the end of that link on top. So there's no continuation, which is what I did before. But yeah, other than that, I hope that helped. Sorry for the little bump, but yeah, that's the end of this problem. Thank you.